math science in 1808 when John Dalton came up with his principles, the law of multiple proportions and the law of definite proportions. He also came up with a third theory.
OMG! I'm a freaking genius! Hey, Avogadro! Come here. Let me show you something.
Hey, Dalton!
Hey, what's up? Hey, see what I've got. So, there's an atomic mass for all the atoms participating in a chemical reaction, right?
Right.
And if there is a compound containing two elements, there should be one atom of each, right?
I don't think so. Because you don't really
Why
have
not?
an accurate method to measure the atomic weights. Therefore, each molecule contains two atoms. See here in the water formula? For two hydrogens, one oxygen interacts with it to make water. Therefore, one molecule does not equal one atom.
What are you trying to say? Are you trying to say that I'm wrong?
Yeah.
I don't think so.
Hey,
I think you're
Terazaro.
right.
No, wait. Terazaro.
Yes.
Do you agree with me or with Dalton?
I think Avogadro's right, because his principle can determine both atomic and molar masses. Sorry, Dalton.
What now? What? Let's go. What? Oh, yeah.
Avogadro's number, which is 6.022 times 10 to the 23rd power, wasn't actually determined by Avogadro himself, because Avogadro didn't have any knowledge of the concept of moles. However, his principle is what helped scientists later determine this number.
Hey guys! First of all, we want to start off with be wise, protect your eyes, and wear your goggles. Next,
This picture is really important. Don't get that picture out of your head. No horseplay in the lab.
now we're going to go and introduce the materials. Tremont, do you want to come?
Sure.
Okay, so we're going to do Avogadro's experiment, and we're going to need 1.0 molars of sulfuric acid, deionized water, and 2 beakers.
We're also going to need acetone, copper electrodes, and wire pliers.
Alright, and in this experiment, we also need stopwatch to record the time. And another material we need is ethanol alcohol.
Did you say alcohol?
Yeah.
Alcohol, I like that too.
Well, I'm sorry for you, girls. This is not that good. And, well, you guys are in high school, so you can't have alcohol anyways. So we're not going to be worried about that. So now we're going to go back to the experiment and how we set it up. So here we start off with our setup and with our actual experiment. This is our power supply with a positive and negative sign. The negative sign is the cathode, and it's usually a black wire. The positive sign is the other one, obviously. Here we can read the amps that the power supply measures.
Alright, here we have sulfuric acid, which has already been diluted to 0.5 molar with 50 milliliters of deionized water and 50 milliliters of 1.0 molar sulfuric acid.
To start off the experiment, we need to go ahead and label the electrode. For the anode, it's going to be represented by the positive sign. I'm going to go ahead and put a white sticker on it. And we're going to go and measure each electrode. We have our data sheet here, pencil, obviously, to write it down. Now here in the balance room, I'm going to go ahead and measure the cathode first. Go ahead and tear it, make sure it's at 0 grams. Now I'm going to go ahead and place it on here. And the measurement is 5.276 grams. And I'm going to go ahead and write it down here. So remove it and place the anode on there. I'm going to go ahead and remove the tape so it won't cause an effect, a big huge effect on it. Place it on there. And the measurement came out to be 5.213 grams. It is very important to know which electrode goes to which cathode and anode for the data. Make sure the power supply is off.
Okay, so we have our measured electrodes here, and just make sure before you set them up and actually connect them here, make sure that the power supply is off. So we have the anode or the positive right here, so we just connect it to the alligator clip. Make sure your electrode is not touching your beaker. Now our setup is ready. So what we need to do next is we start off the stopwatch and the power supply at the same time, and right here where we get the numbers in amps, it better be somewhere between 0.1 and 0.5, and the lower the better. So we go ahead and start off the stopwatch and turn on the power supply, and we record the numbers every minute, and we have to do this twice. I try to get the number somewhere around 0.2. Okay. As we can see right here, we see just a very gentle reaction with some bubbles coming out of the cathode side. So we ran the first trial and we recorded our data for 10 minutes, which they are recorded here, and they are in amps. So the next thing we need to do is just we change everything. We change our electrodes, and we change our acid, and we try a new set of trial. As you saw earlier, after I removed everything, I have my old electrodes right here, and I have my ethanol alcohol. So I pour some of the alcohol in the beaker. And put the electrodes in here in order to rinse them out. Then I'll go ahead and put them here to dry, and then we need to measure the mass of the electrodes after the experiment one more time and compare it to the initial mass. So while I'm waiting for these to dry, I can go back to the next set of trial. I already prepared my electrodes, and I weighed them, so they're ready. Okay, I have my new acid prepared here in the beaker. So now I'll just go ahead and do the exact same experiment one more time in order to get the average number of all all the data within 10 minutes. Now we're done with the second set of experiment as well. I went ahead and measured the old electrodes and recorded the new mass. I'm just gonna go ahead and do the same to the second set. So now we're done with our experimental part. We have our numbers here, the second and first set. So now what we need to do is just go ahead and do the calculation right now to get to our Avogadro's number. After we're done with our experiment, we can go ahead and discard everything down the sink with plenty of water.
Water for diluted. Yeah. Oh my goodness. And if you get any corrosive. And then here we have the sulfuric acid, which has been diluted with 0.50 of
I'm going to mix 2 atoms. You can tell by the water.
100. Is that 100?
Developed as a exact science in 1808. Multiple proportions and the law of definite. Avogadro's number.
I don't want to be in there.
So, here's our professor, Dr. Gilbert.
And this is our professor, Dr. Gilbert.
He hates being hooked.
Here comes out the good stuff. Alcohol. Sorry. No. You know what? Do it again. No, it doesn't sound good. Oh my god! I figured it out! I'm a freaking genius! I finally figured it out!